Okay, so I just thought I would start a video and start talking about how to do a combination circuit. Okay, so let's say I have a 100-volt power supply. Okay, and I have a 10 ohm, a 20 ohm, a 5 ohm, a 15 ohm, and a 30 ohm, all connected in this type of pattern. Well, here's the thing. So the idea, before I can actually solve it, I need to kind of simplify it a little bit. So I need to try to create and condense all of these little pieces into one single circuit. Okay, so I can see that this resistor is series to that resistor, which is series to this whole group. Okay, so somehow I'm going to try to condense this one down into its own resistor. Well, these two are series to each other, so I can combine those, but they are parallel to this resistor. So I'm going to have to take it in steps. So I'm going to show you the pathway that I take. So I'm going to recreate these drawings, a few times, so that we can get a pathway. Okay, so there's the battery supply, and I'm not going to change that 100 or that 10 ohm, but I am going to convert the 3 and the 4 into a single resistor. Okay, and then I'm not doing anything with resistor 5, so I'll keep that going. Okay, so that's still 10 ohms. This is still 100 volts. Okay, that's still 20 ohms. Now, because these two are series to each other, I can just directly add them. Okay, so 5 ohms plus 15 ohms in series would give me another 20 ohm resistor equivalent. So that's like resistor 3 and 4 combined. This is still resistor 2, that's still resistor 1, and this is resistor 5. Okay, and that would still be 30 because I didn't change anything. So as I start to, calculate things, and as it starts to kind of unravel, I can plug them into my chart and keep track of that. Okay. All right. So now my next step. So this is series to that one, which is also series to this whole group, but these two are parallel. So the current's going to come in from the battery supply through that resistor, and then it's going to branch off. Okay, into two pathways, right? And then it's going to recombine so that it can come back to the battery supply. Okay. So I can take these two resistors and I can combine them as a parallel. Well, let's do that. So because these are parallel, they actually add reciprocally. So the resulting resistance, 1 over R, and I'm going to actually label it with the number. So 2, 3, 4 combined, right? So that's the total of them, equals 1 over R2 plus 1 over R3, 4. Okay? So basically 1 over the R2, 3, 4 then would equal 1 over 20 plus 1 over 20, which is equal to 2 over 20, right? Which equals 1 over 10. So I can reduce that. Now, that means that 1 over the resistance is equal to 1 over 10. So the combined resistance then would equal 10 ohms. Okay? So then I can redraw this after combining them. There's my 10 ohm resistor. Now this would be the equivalent of all of those resistors. So that's R1. Now this would be R2, 3, 4 combined, that whole group here, okay, which we just calculated was 10 ohms. We know that this resistor was 10 ohms, and then we know this resistor was 30 ohms, okay, and that's still 100 volts, okay. Now that I've got it condensed down into a simple series circuit, now all I have to do is just add those together. So it's equivalent then would be, if I were to condense all of this into one resistor, what resistor value would that be? Well, that's the equivalent. So that would be 10 plus 10 plus 30, which is 50 ohms. Okay, and that's 100 volt. Okay, so that's what my total then would be. Well, now that I calculated that, I can put it up in my chart. So that would be 50 ohms is my equivalent resistance. Now, once you start solving these things, it's going to start to open up that pathway of what do I do next? So I'm going to start here, and then I'm going to keep working backwards until I get all of my values all taken care of. Okay. So now that I have this, I can use basic Ohm's law, V equals IR. Okay. My voltage is 100 volts. My current is what I'm solving for, and my overall resistance was 50 ohms. So then my current then would equal 2 amps. Okay, so I have 2 amps going through the entire circuit. Okay, so there's 2 amps. Okay, now if I look at that, because these are all in series to each other, they all carry the same current. So resistor 1 has 2 amps going through it. The 2, 3, 4 total combo has 2 amps coming through it. And then our 5 also has 2 amps coming through that. So now that I know that, I can go ahead and plug in, well, 2 amps is in resistor 5, and then 2 amps was going through resistor number 1. Okay, now all 3 of these together would end up being 2 amps. Okay, so we'll see what happens there in just a second. Okay. All right, now that I have 2 out of the 3, I can just go ahead and solve for its voltage. Well, V equals I times R, so then that has to equal 60 volts, right? 2 times 30 is 60, and then 2 times 10 would be 20 volts. So resistor 1 is done, resistor 5 is done. Now I got to focus on this combination circuit here, okay? Since 2 amps is coming through resistor 1 to this branch, that means together those have to add up to 2 amps. Well, now luckily, I showed you that this is 20 and that's 20. So if it's the same resistance, that means that the currents have to be equal. So if I have 2 amps coming in, well, half of the current goes through the first branch and then half goes through the next branch. So that means that that would be 1 amp and that would be 1 amp as well. Okay? Or you could look at it in terms of this. Since the voltage across resistor 1 is 20 volts and the voltage across this number 5 was 60 volts, then what's coming across this entire branch has to be the remaining of the difference. So that would be 20 plus 60 is 80. Then that means that this whole branch has to be 20 volts. Well, remember, in parallel, they have the same voltage across each one of them. So 20 volts would be here, and 20 volts would be here. Okay? And that shows me that I can get that 1 amp. Now, since I found out what that current was, R2 would be 1 amp, okay? Well, then that means that would have a voltage of 20 volts. And that confirms it. Well, since it splits the current here, that's 1 amp also. Well, 1 amp goes through 3, but it also has 1 amp that goes through the 15 ohm resistor as well, because it's the same current going through that same branch. So now that I have that, well, 5 times 1 is 5 volts, and 15 times 1 is 15 volts. And there you have it. I've solved the combination circuit. So basically what I'm trying to get at is that when you get a complex circuit like this, you try to condense it down into simple circuits and solve them piece by piece. As I start to combine these two, then it opens it up to that being a parallel. And then I can combine those two parallels and it shows you that it's a series circuit. Once I get it into its simple version of it, then I can go ahead and do the rest of the math. Okay? Well, I hope that helps. Good luck.